Let's have our lecture video in Engineering Economics. And the topic is Annuity. Now, what is annuity? So we have here, annuity is a series of unknown payments made at equal interval of time. Annuities are established for the following purposes. Number one, as payment of a debt by a series of equal payment at equal time intervals, also known as amortization. Number two, to accumulate a certain amount in the future by depositing equal amounts at equal time intervals. These amounts are called sinking fund. Number three, as a substitute periodic payment for a future lump sum. We have here the elements of annuity. We have A, the periodic payment, the one being paid in an equal interval of time. P, present worth of all periodic payment. F or S, future worth of all periodic payment for and after the last payment is made. I, interest rate per payment. And N is the number of payments. Now, there are types of annuity. The first one being the ordinary annuity. So what is ordinary annuity? In ordinary annuity, the payment is made at the end of each period starting from the first period as in the diagram shown below. So this is the diagram. Okay. So let's consider this as the year zero or the origin. So here after the first year, so 1 year has passed and you can have here the first payment A, the second year, the second payment of A, the third year, the third payment of A, the fourth year, the fourth payment of A, and so on and so forth until you reach the last payment period and you pay there the last amount of A. So to calculate for the future worth, we have here the formula. F is equal to the equal payment being made at an equal interval of time multiplied with 1 plus I raised to the power of N. Now take note that N is the number of payment made minus 1 all over I. Now, how do we compute for the present worth? Now, for the present worth, we have here the formula for future worth. For the compound interest, we have there F is equal to P 1 plus I raised to N. N being the number of years, number of periods. So we have here P is equal to F all over 1 plus I raised to N. So P now is equal to the F, the value of F is A 1 plus I raised to N minus 1 all over I. So all over I, then 1 plus I raised to N. So that is the formula for the present worth. But let's change the exponent here. Knowing that N for the future worth formula here means the number of payment made, and then the N here is different because it is the number of periods. So we can change this or we can have this as M or the number of period, so that we can differentiate which one is the per payment and which one is per period. Okay, so that's how we get the formula for present worth. How about the second type of annuity? We have the deferred annuity. In this type, the first payment is deferred or it is delayed a certain number of periods after the first. Consider the cash flow diagram shown below. So this is the cash flow diagram. So having this as the the year 0 as the origin, notice that in this cash flow diagram, there is no payment made for the first year. Rather, the payment was made at the second year. So, if we are considering 5 payment period, so after the 5th year, and then the payment was made at the beginning or at the second year only, so we have here the number of payment as 4. There are 4 number of payments made, but the number of period M, so let's put this as M, is equal to 5. So that's the difference. So for future word, we have this formula again, same formula with the ordinary annuity, but you have to remember that N here is the number of payment. So in the example, our N is 4. So F is equal to A multiplied with 1 plus I raised to 4 minus 1 all over I. Now to compute for the present worth, now for the present worth that we have computed a while ago, we have their present is equal to, okay, so it's already here, so we can remove this part here. So we have A multiplied with 1 plus I raised to the number of payment minus 1 all over this portion here, 1 plus I raised to the N here is the number of period. So that's the number of period multiplied with I. Okay, so we can remove this part already. So this is the present word formula without this part. Okay, how about the third type of annuity? We have the annuity due. If the payment is made at the beginning of each period, starting from the first period, the annuity is called the annuity due. So notice from the diagram below, so we have 5 periods, but we have here, so we have here 5 periods, this is M, but we have how many payments? If the payment is made at the beginning, so we have N is equal to 6. And again, if we recall the definition for annuity, we are to consider the last payment. So that's why we have here the total of 6 payments, including the beginning. Okay, so let's have the formula. So this is the cash flow diagram a while ago. So from this cash flow diagram, we can derive the formula for future worth. Again, notice that N here is the number of payment. That's why we put here 6. But for the present worth, the N here is 5 because that is the number of period. So that's the difference. Now to summarize, the formula for P, it's put here already. P is equal to A times 1 plus I raised to N minus 1 all over 1 plus I raised to M times 1, where erase this part here, where N is the number of payments, and erase this and replace with M. Okay. And M is the number of periods from 0 period up to the last period. So these are the 3 types of annuity. Let's try to solve the examples so as to practice what we have learned. Number 1, what amount would have to be invested at the end of each year the next 8 years at 4% compounded semi-annually in order to have 5,000 pesos at the end of time? So we are having here some confusion because we are talking about each year here, but the payment is semi-annually. So we need to put it in a simple term. So this is complicated because we're talking about investment of each year, and then the interest rate is semi-annually. So we need to convert first. So to convert, recall that we have here the effective rate. So, let's put first the conversion effective rate of, we're going to get the annual effective rate. So effective rate given is, we have there semi-annually. So we have there 1 plus I raised to 1 minus, so this is for annual, so minus 1 is equal to 1 plus, the problem is 0.04, that is semi-annually, raised to 2 minus 1. So how we come up with this, you can watch from the previous videos how we did the conversion. Okay, so calculating, we have the value for I is equal to 0.0404. So that's what we are going to use for the situation of annually or each year. Now, what is being asked, by the way, in the problem? So what amount would have to be invested at the end of each year? So it's asking for the annual payment. How about 5,000 pesos here? What's that? Is that the future or the present worth? So it says there, in order to have 5,000 pesos at the end of the time. So that is a future worth. Now from the previous example, from the previous discussion, we have the formula for future is equal to, so we have here the annual payment, 1 plus I raised to the number of payment minus 1 all over I. Now the question here is, what type of annuity are we talking about? Is it ordinary annuity that is being paid at the end of each year? Is it deferred annuity wherein the payment is delayed? Or is it annuity due, that is the payment is being made at the start of the period? So the word there is at the end of each year. So we are talking about an ordinary annuity. So for 8 years, if we draw the cash flow diagram for that, so each year, so this is year 0, 1, 2, 3, 4, 5, 6, 7, 8 periods. Okay? So in each period, there is a payment of A. So we are being asked to find the future worth of all of this, and the number of payment is equal to 1, 2, 3, 4, 5, 6, 7, 8. There is 8 number of payments. Therefore, F now is equal to, or F is already given, by the way, because F is 5,000 pesos. So we have here 5,000 is equal to A 1 plus I. So we computed the I as 0.0404 raised to how many payment? 8 minus 1 all over the I of 0.0404. Now what's now the value for the annual payment? Annual payment now is equal to 541.87 pesos. So that's for number 1. So number 1 is ordinary annuity. Let's go to number 2. A contractor bought a concrete mixer, may be paid 120,000 pesos in cash. The mixer may also be purchased by installment to be paid within 5 years. If money is worth 8%, the amount of each annual payment, if all payments are made at the beginning of each year, is what? Okay, so there are two situations here. So there's a contractor who wants to buy a concrete mixer. He can pay it 1,200 pesos in cash. So goes there and pay it in cash. But he can also have the option of purchasing it by installment. So yearly, he is to pay it within 5 years. So having the money worth 8%, the amount of each annual payment, if all payments are made at the beginning of each year, so at the beginning of each year, so this is an example of annuity due. So this is an annuity due example. It is asking for the annual payment. If we draw the cash flow diagram for this, so 5 years. So this is year 0. We have here 1, 2, 3, 4, 5. We have there 5 years. And then the payment is made at the beginning. So payment here, first payment, second payment, third, fourth, fifth, sixth. So there are 6 payments. So we have there n is equal to 6. Now what is being asked is the value of A. What is 120,000 pesos here? Is that the future or the present worth? Remember that the situation there is the contractor can go in that store and buy something for 120,000 pesos, not delaying it for another 5 years. So this 120,000 pesos is actually a present worth. So it's a present worth, therefore, so our arrow here will travel to the present. So for the present worth here, so it's traveling to the point of origin. So have here point of origin. P is equal to 120,000 pesos. Okay. Now let's solve here for the formula for the present word, if we recall for the formula here, present word is equal to annuity times 1 plus I raised to n minus 1 all over I 1 plus I raised to m. So that is P is equal to A, or P is given, actually it's already given here. So that is 120,000 is equal to A 1 plus how many percent in the problem? It is 0.06 raised to how many payment? There are 6 payments minus 1 all over the I here is it's 0.08. It's 0.08. So I is 0.08 times 1 plus 0.08 raised to 5. So we can calculate now for the value of A. So that is equal to 24,035.04 pesos. Okay. So that's for number 2. Next we have number 3. So you need a 40,000 pesos per year or 4 years to go to college. Your father invested 50,000 pesos in a 7% account for your education when you were born. If you withdraw the 40,000 pesos at the end of your 17th, 18th, 19th, and 28th years, how much money will be left in the account at the end of your 21st year? So actually this problem is kind of tricky, but let's try to solve it one by one. Okay, so you need 40,000 per year to go for a 4-year college course. But your father already planned it ahead. So when you were born, he immediately invested 50,000 pesos with a 7% in the account for your education. So when you reach your 17th year, you need to withdraw the 40,000 for your college payments. Another withdrawal is made at the 18th. You withdraw again for the 19th and then for the 20th years. Then it's asking how much money will be left upon your graduation. So how much money is left for you to find a job at your 21st year? So let's draw for the cash flow diagram for us to fully visualize what's happening. So let's point this as the year 0. And let's cut this. So let's put here 16. This is the 16th year, for example. So this is now the 17th year, the 18th year, the 19th year, and the 20th year. And this is the 21st, the time when you graduated. This is the 21st year. So to solve this, we need to compare if for the amount of money at the end of 21st year, if you're not withdrawing the money. So we need to find out what is the 50,000 pesos worth in 21 years. So let's have the portion here as the cash inflow. So the positive part of the cash flow. So let's say that without touching the money, how much is your money in your 21st year? So we will be looking for the future worth here. Let's put here the future worth 1. Then at the negative part here, let's consider that as the cash outflow, wherein you are withdrawing money at your 17th year, at your 18th year, 19th, 20th year. All these are 40K. 40K, 40K. So A here is 40K. So what will we do now? So considering all this future, all this payment, we need to get the future worth here up until the last withdrawal, which is the 28th year. So considering that part here, so we made 4 withdrawal, we will have this as the future 2. Then for us to compare with the future 1, we need to go to the 21st year. So considering F2 as the present, let's jump to future at 21st year. So this is your F3. So if you notice, they are all aligned here at this portion. Okay. So having the F2 here, convert this into a present. This becomes present here, and then move to future 3. Okay, so let's compute that. First, let's have the F1. So for the F1, we have the formula present 1 plus I raised to n, and that is equal to the present worth is 50,000. So P is equal to 50K. So we have here 50,000 pesos. 1 plus the I here is 0.07 raised to the, how many period? We have there 21 years. So F1 is now equal to, so let's concentrate on the cash flow diagram. So F1 is equal to 207,028.12 pesos. 207,028.12 pesos. Now let's find the value of F2. So for F2, what's that? Let's compute for the annuity. So we have there A 1 plus I raised to the number of payment minus 1 all over I. So that is F2 is equal to 40,000. You are withdrawing 40,000. 1 plus 0.07 raised to the, how many withdrawal? We have there 4 minus 1 all over I of 0.07. So F2 is equal to 177,597.72 pesos. Now for F3, that is equal to, the formula for F3 is present worth 1 plus I raised to N. Future 3, having P as F2, so the P here becomes 177,597.72 multiplied with 1 plus 0.07 raised to how many year? 1 year. That is equal to 190,020.29. So 29.56 pesos. Now to get now the money left, so it's asking how much money will be left in the account at the end of your 21st year. So money left, is equal to F1 minus F3. F1 is 207,028.12 pesos minus 190,029.56 pesos. Money left is now equal to 16,998.56 pesos for you to find a job. So that's how much money you have left after your graduation to celebrate or to find a job. Okay, so that is for example number 3. So the last one, we have example number 4. How much money must you deposit today to an account earning 12% so that you can withdraw 25,000 pesos yearly indefinitely at the end of the 10th year? Indefinitely. So remember, in the compound interest, we have the continuous compounding. So we also have here a continuous annuity. So we have there indefinite. The formula for this situation actually is P is equal to annuity over I. So that's the formula. Okay, so let's have the cash flow diagram for this. Deposit. How much money must you deposit today? So it's asking for the present worth to an account earning 12% so that you can withdraw 25,000 pesos yearly indefinitely at the end of the 10th year. Okay, so we have here, let's put it as year 9, year 10, year 11, year 12, and so on and so forth. Let's put an arrow here, which means we are dealing with an indefinite period. Okay? So, on what period are you withdrawing? So, you are withdrawing at the end of the 10th year, so this one here. At the end of the 10th year, so this is your 25K withdrawal. At the end of the 11th year, at the end of the 12th year. So of course, this is the end of the 10th year, because if we have this the year 1, you cannot put the end of year 1 here at year 2. No. So what we did here is correct. The end of year 10 is here. So how much money must you deposit today? So we will be solving backwards. Excuse me. So let's take here from the indefinite period up to here. So we will be taking the present, considering all the yearly payment of 25K. Let's have the present at the beginning of the withdrawal period. And then from this portion, we will put here present 1. Okay, let's put this as present 1. And then from this present, we will be finding the another one, the present here at the period until the origin, the beginning. So this is the present 2, which is being asked in the problem. The amount of money you are to deposit today. Okay. So we have here first the present 1. To compute for the present 1, we have there P1 equal to A over I, the annual payment of 25K regardless of how many payment, because you don't know the exact payment because it is indefinite. I here is 0.12. So P1 is equal to 208,333.33 pesos. Now having this present I, present 1, and then solving for present 2, we will be considering present 1 as the future of present 2. So that to compute for P2, we have their future is equal to P2 1 plus I raised to N. P2 is equal to F over 1 plus I raised to N. Then we have here P2 is equal to, the future here is the P1, which is 208,333.33 pesos all over 1 plus 0.12. How many payment period? So we are dealing with this portion here, and the end of P1 is 9. So we will put here 9 years. So P2 is equal to 75,127.09 pesos. So this is the amount that you will deposit today at year 0, so that you can withdraw 25,000 pesos yearly indefinitely at the end of the 10th year. So this is another example of deferred annuity. Payment or withdrawal is being delayed.